Hello friends, here in this video we are going to see what is meant by maximum principal stress theory. Now, maximum principal stress theory, here it means that when we are talking about principal stresses are tensile stress and compressive stress. So it means this theory basically deals with tensile or compressive stress, and it states that, here I'll write the statement of that. Now, here I have written the statement for maximum principal stress theory. It states that the failure of a material or a component will take place when the maximum value of stress exceeds the limiting value of stress. Now, let us try to understand what is the meaning of this by drawing a diagram. Now, here I'll draw two stress strain graphs. The first one. Now, here I have two different graphs. The first graph which I have drawn, it is for ductile materials, and the second one which I have drawn, it is for brittle materials. Now, as we can see in the first graph, that is for ductile materials, when we are increasing the stress, strain also increases, and there is a point in this graph, that is point D, where we are having maximum value of stress. Now, from this graph it is clear that after the maximum stress has been reached, then there is a region from D to E in which even if the stress goes on decreasing, the strain value increases, and finally at point E the material breaks. So if in any material the value reaches the maximum value of stress, then after that maximum value has been reached, that material can break anywhere. So the chances should be to avoid the material to operate in the maximum stress condition. We have to reduce the working stress so that the material does not reach maximum stress. So this is for ductile material. Next, check it for brittle material. Brittle material, as we know, it fails without giving any prior warning. So when we are increasing the stress value, the strain increases, and finally there is a point where the material breaks, and at that point the stress is called as sigma ultimate, that is ultimate stress. So as per the definition or the statement of maximum principal stress theory, here we have written that it states that the failure of a material or a component will take place when the maximum value of stress exceeds the limiting value of stress. The limiting value of stress is here the maximum stress, and then if we are increasing the stress from this value, that is point D has been reached, then the material can fail anywhere. Similarly, for brittle materials, as we can see, if the material has reached ultimate stress value, then it can break anywhere. So, as per the maximum principal stress theory, working stress or permissible stress for ductile materials is given by, we need to reduce the value of working stress so that it doesn't go into the maximum stress condition, and for that we have to use factor of safety, that is the permissible stress. I'll write down sigma permissible will be equal to, since we are writing for ductile materials, in case of ductile materials the maximum stress, it is also called as yield stress, sigma suffix y, so it is yield stress upon factor of safety. So therefore the permissible stress will become sigma y upon FOS. So it means if we can use this relation, we can reduce the value of stress, which is the working stress, and the material will be it, we can avoid the failure of that material. Next, similarly, working stress or permissible stress for brittle materials is given by the permissible stress. For brittle materials, the maximum stress at which the material breaks, it is called as sigma ultimate, that is ultimate stress upon factor of safety, which is sigma ultimate upon FOS. And as we have seen, in case of the maximum principal stress theory, we are only using tensile and compressive stresses. Here we are not considering shear stresses, and hence this theory, it is used for brittle materials mostly because they are stronger in shear as compared to the ductile materials.